Hi and Assalamualaikum everyone. My name is Amirul Haras Zaman and my metric number is 206723. Okay, today I gonna explain to you about kinetics of rigid body. What is kinetics? Kinetics is study of forces that cause motion. Kinetics can be divided into three components, which are rotation, general plane motion, and translation. Rotation is the object changes in orientation. The example of rotation in real life is gear. Next, general plane motion. General plane motion is the combination of a translation with a rotation. The example of general plane motion in real life is concrete culvert on the truck. Next, translation. Translation is the object maintains the same orientation. The example of translation in real life is car. Translation can be divided into two components, which are rectilinear and curvilinear. Rectilinear is all points of the object move in straight lines, while curvilinear all points of the object follow curved path. Okay, now I will explain to you about a method. Firstly, we need to create anti-coordinate system and state the acceleration of mass center, which is AG. Then, we need to draw a FBD and kinetic diagram with all the external forces. After that, we need to identify unknowns in the diagram, so we can plan how to solve our equations. By identify our unknowns in the diagram, we can apply the equation of motion, which is summation of fx equal to magx and summation of fy equal to magy, summation of mg equal to 0 or summation of mp equal to summation of mkp. Note that friction forces always oppose the motion of the body.
Hello, Assalamualaikum. My name is Khairul Nashran bin Anwar, matrix number 2051555951. Okay, for the explanation on the application, we choose a translation motion. Let's take a look of the problem. The toy cart with a mass, with a mass 0.2 kg and a mass center gravity which is point G, and then is subjected 0.8 Newton horizontal force pulling it into the left, and the question asks to determine the acceleration of the car, as well as we know the normal forces at the point A and the point B. Assume the wheels are the free to roll and have an angular mass. And so from the procedure for analysis, we need to specify the sense and the direction of acceleration of the mass center, which is obviously is going to move horizontal to the left. Therefore, this kinetic diagram showing only linear acceleration pointing to the left. Then we started to solve the problem with our Fibonacci diagram. We have a normal force at the point A and the point B, and the weak force at the point G. So we set up our coordinate system, and now we are ready to write our three equation of motion. First we have a resultant forces and the acceleration. Fx is equal to mass times agx. Since we have just one force at the acceleration, 0.8 Newton is equal to 0.2 times agx. Agx will be given, we will get 4 meter over second squared. So we know the resultant forces at the y direction will be equal to 0 because the toy car is moving horizontal, and a plus nb minus 0.2 times 9.81, which is represent to the weak force, is equal to 0. So for our third equation, we summarize the total moment about any arbitrary point, but convenience we are going to summarize the total moment about point G, because the translation moment about point G is equal to 0 since there is no angular acceleration alpha. Therefore, this is our equation, and then we can get the third equation from the Fy equation. Just substitute equation 3, the third equation into the second equation, we can get the answer, and A is equal to 0.114 Newton and B is equal to 1.83 Newton. For the conclusion, the knowledge of kinetic rigid body is very useful to solve a problem application in our real life, especially for engineering field. I think that's all for me. Thank you.